Perfect. Crisis avoided. All right. Um, okay. Can you see that? Great. All right. So Smart Design. Smart Design is a strategic design firm and an innovation consultancy that we've been around for almost 50 years now. We kind of range between 50 and 80 people, kind of depending. We started off as an industrial design uh, group, and then we've kind of like evolved throughout history. So originally 50 years ago, we were known for designers only. And then because of that, we decided to add a mechanical engineering group so that we could prove that we could not only design things, but we could build them too. And then right around the age of technology, we moved into doing more of like like design strategy and also strategic on like the digital side. And we added like an interaction design component to it. And then over the last 10 years, we've developed a technology group that has really been growing in the last 10 years. And one of the things that we've seen that I'm actually going to explain a little bit later is that like um, because of our heritage in physical design, um, we've seen just a huge amount of growth within like the IoT connected product space because we have the heritage of building things, and then we've been working on screen-based technology for a very long time. The ability to kind of like put those two things together, we've just been seeing an immense amount of growth on that. So that's a lot of the work that currently I do a lot of now. But just a little bit about Smart. Another one small little piece about Smart Design is that we are independently owned, and so that makes us a little bit different from the other design consultancies that are out there, like Frog and IDEO as an example. Um, we just opened, so we have been in New York as our home base for the entire 50 years, and we were always in Manhattan. But over the pandemic, we decided to close up shop in Manhattan, which was on the west side on West 26th and 11th. And we decided to move to the Brooklyn Navy Yard, which is this really cool space where these old World War II ships were made, and we converted it into this really neat innovation space where it really kind of meets the needs of what we need to do as designers. Where not only is it like a place for us to work, but also because we do a lot of physical prototyping and we do a lot of electrical engineering, we need that place to be able to do it. And so we have a full shop where we can do everything from designing or developing everything from wood to silicone to metal. And then we have a whole electrical shop where we do our own PCB boards and a lot of like some custom electrical engineering work. We have a whole room full of 3D printers. So it's a really cool space, and we do events all the time. So if you're ever in New York or you live in New York, follow us on LinkedIn or whatever. And yeah, come on by the studio. It's a really cool place. And we host the New York hardware event pretty frequently, which is something that I've done as well, and it's super fun. And actually, the last time we did it, I did the stock. So there you go. Like Dev said, my name is John. I'm a partner at Smart. My history is in software engineering. I've been a software engineer for about 20 years. I started off as a backend engineer, and then I did some like really large web builds. That's kind of where the Sesame Street thing came from. And then I started focusing a little bit more on front end and then also like some really big, large mobile cloud infrastructure type builds. And then over my last 10 years at Smart as like a design consultant, I kind of pivoted from like the really heavy duty coding stuff to thinking about, well, I would love to work at a design company where we can kind of bring a lot of like the engineering componentry and some of the knowledge that we have of just being developers and engineers to the design work. And so I started at Smart about 10 years ago. I was the first technology full-time hire. And then now to this day, I would say there's probably interchangeably, engineering is the largest group if you include the mechanical engineers. But right now we have about between 15 and 20 full-time to part-time full-time to freelance employees that are working either in full-time back-end engineering, front-end engineering. We're seeing a lot of like embedded systems and robotics work. And so we're really kind of like growing out that team, which is really exciting. So I'll now go into what we're going to talk about today, which is so the last 20 years was a major leap in consumer-based technology, but more specifically, screen-based technology. And so from like the birth of the internet to personal computing to smartphones, a lot of the times when we talk about building technology, it's been on the idea that the vehicle of it, of how we interact with it, is with a smartphone. And when I first started my career, websites were much more creative, like brand expressions. And that, like as an example, I think I don't remember how it says on the tech check or in my intro, but I built a website for Marc Jacobs. It was the first website I ever built when I moved to New York, and it was for the perfume component of it, Daisy. And the site itself had a whole login system. Um, there was like 7 or 8 games that we built into it, built in Flash, and it was just like this huge monolith of a website that like would never really kind of exist now. And again, it was like more about like building up a brand than it necessarily was about like a product. And so the evolution that kind of happened, and really it happened with the announcement of the iPhone, was that websites then became, or any sort of screen-based technology product became much more utilitarian. And so the evolution of like front-end experiences became much more useful than they were creative. Now, I know there's a lot of people on this call, including myself, that always try to build in creativity into front-end experiences. But the beginnings of user experience design and digital experiences, I really remember that coming through within maybe the last like 15 years. And so companies like Smart Design, who we like Dad said, like where we pioneered the idea of inclusive design and user experience design with companies like OXO, where we're taking like physical products and we're coming up with design systems where in that case we would use edge case scenarios like professional chefs and people with arthritis. And if we can design something for the two of them, then everyone would fit in the middle. We would use that same sort of design mentality and then pivot that towards into more digital strategies. And that was even more true when it came to mobile, where not only were people using it from like a brand perspective, but they're also using it like the what and the how, but also like the where became really important. And so I remember one of the first mobile apps I ever created was the first app for Citibank, and they just wanted to recreate like the website for Citibank. But in actuality, like the whole component of why they were doing it and where they were was so important to some of the mobile creations that we would do for until now, that it was like a whole new era that was kind of being ushered in. And so yeah, and so we kind of keep that ethos to this day. And so you flash forward to now, and there's just a lot of like front-end experiences that are just a lot more mature. Frameworks like React.js, and Google's material design, and then even like something like Squarespace. It's kind of like it's kind of taken away like the creative flexibility, and it's kind of like set what the front end experiences are really like. And so oftentimes when we design like mobile applications, there's a certain like interaction expectation on how things are going to work, especially like from an iPhone perspective, that like those innovations are a little bit fewer and further between. There's obviously some much grander ones you can make from like a business perspective or a product one, but it's a little bit trickier from a user interaction perspective because people are so set in like how things work. And so where will new design come from? And so there are all sorts of new technologies that are coming out, like reality-based ones that are AR and VR, and security-based ones like blockchain. But then there's more tangible ones that are coming up, and it's ever more relevant over the last 2 years, which is around machine learning and AI. And those are the things that I want to talk about. Luckily, there have been innovations recently that are driving the force of artificial intelligence. So these are the three main ones, and these are the ones that we're seeing the most of out of the work that we're doing. So the first one is GPUs. Obviously, from NVIDIA's market cap, everyone's kind of aware of NVIDIA, but the ability for NVIDIA to unlock some not necessarily new algorithm-based work, but it allows it to work and computationally a lot faster. Very similarly, when the internet first came out and JavaScript was invented, but the internet wasn't fast enough for JavaScript to work, and so it took some time to work. It's the same kind of thing with GPUs and neural networks, where neural networks have existed for a really long time. But what GPUs offer is just like the time it takes for an inference to propagate is just so much faster, and so it really allows that technology to really sing in digital products. And so those two things, and then the other is smart sensing, specifically in IoT products. And really those are like the fact that those things can be so connected, they use low power, and they're being invented all the time. And so as an example, um, I'm building right now a home product that is using like certain gas sensors. And 10 years ago, when we first started looking at this, there weren't really any gas sensors that were really available outside of like carbon dioxide and oxygen sensors. And then now when we look, every single sensor from like ethanol to ethylene is all like readily available and being used. And so all that kind of reminds me is that like people are generating that demand. And so like all of a sudden these new types of smart sensing are becoming available, and those are driving all new types of products and services, either that from like a startup perspective or from a company that's like a Fortune 500 company that's trying to go into a new space. And then this is the slide that tells you that people are investing in AI. But yeah, obviously, Goldman Sachs predicted that we're going to be investing $1 trillion in artificial intelligence over the next 5 years. I think I grabbed this slide, or I found these numbers maybe 2 months ago, and so maybe it's 2 trillion by now. But obviously, AI is a big talking point, and I don't think I have to talk about that any further. So I've broken up AI into three main buckets. And I'm only going to be talking about one of them because this could be a much larger conversation. But the first is like using AI and machine learning and like business intelligence, like how financial institutions use them to create models, to obviously understand like things like currency and all sorts of different complicated pieces. So there's that. The second is obviously a little bit more new, which is generative AI, which something that at Smart Design over maybe the last year, we've really seen a lot of work in this space, not only from like a client-facing work that we're doing with developing AI tools for larger tech companies, but also we've even been developing our own large language models to see if we could be just a little bit more efficient. As an example, like we've developed a large language model to organize some of our qualitative research, because a lot of that is like very time consuming, but it doesn't necessarily unveil anything besides like anything organizationally. And so we're developing large language models actually to make that better or faster and more efficient, so that we can deliver better solutions to our clients a lot quicker and faster, and cheaper, which is the most important thing. So that talk is pending, but that's not going to be what I'm talking about. What I am going to be talking about, and is the topic of this entire talk, is developing AI for the Internet of Things. And really, what that really means is developing custom proprietary data sets that could be the backbone of an entire business. So if you think of Fitbit as an example, I know it's not like the best example now, but Fitbit built an entire brand on steps. And steps aren't steps. Steps are an algorithm based on an accelerometer and a gyro that creates an algorithm of steps that then is able to calculate those pieces, and then that they're able to turn that into an entire business. And so what I'm going to talk about is just generally like over like the last 10 years, we've done a lot of products in this space, and how you can pilot and do R&D when you're doing specifically things with Internet of Things. So the one that we're going to be talking about specifically is the GX ecosystem. I have a video that's going to explain this, but we've been working with Gatorade over the last 9 years. Gatorade as a company, they dominate the market share of sports fuel hydration. I think they're like 80% of like the entire market share of that. But they're starting to look at themselves and seeing like, all right, well, what does the next 50 years of Gatorade look like? Because there's a lot of brands that are coming out that are kind of like taking away like pieces of what they offer. And so what is the next piece of that? And so we worked with Gatorade on developing this hypothesis that would then drive this whole new piece of innovation. And so I'll start right there. And then just let me know if
Just
the
as
sound
athletes
works.
never stop pushing to improve their performance, Gatorade never stops working to create superior sports fuel solutions. With the introduction of GX, Gatorade pioneered sports fuel personalization. Now we're using GSSI scientific expertise and our access to top sports teams to take GX to a new level. We've significantly expanded the program, partnering with many of the best teams in the world in the NFL, NBA, G League, global football, and top college programs. After extensive on-the-field testing, we're applying what we've learned to our latest product portfolio. At the pro level, we're launching an improved version of GX with a wide range of formulas and an enhanced digital platform. For the consumer, we're offering GX pods and bottle customization through e-commerce. We're also working on further enhancements of the GX Sweat Patch, which will allow athletes to unlock their unique sweat profiles to create personalized fuel strategies. There's much more to come.
That's it. Oh, sorry. Okay, great. All right. So the whole idea of the GX ecosystem is this idea of personalization. And so this could be like a whole other case study talk, but what we left like our initial work sessions was this idea of like every athlete is unique. And we wanted to pilot some of these like ideas to see if they would actually work. And so we started with the Brazilian national team, and we developed these like custom formulas for each team, and we tested them in a lab. And as soon as we tested them in the lab, we developed these formulas that were based on like how much they sweat and the concentration of their sweat. We could give really acute formulas for what they should use for hydration. And as soon as we gave it to them, we put their names on the bottles and we gave it to them, they loved it. And so we then took that pilot and we brought it even further into, we worked with Premier League Soccer, NFL, NBA. I didn't get to meet Messi, but he was in a room that I was also in, so I could see him. But this whole like idea of personalization just like really flew off, and it worked really well. And so the issue with it though was that it worked really well with the pros because they just had the infrastructure and they had the lab to be able to do this. So the way that it initially worked was that we would have a bunch of sports scientists go to like an NBA team. They would get tested in a lab where they would wear these patches, and they would be weighed before and after activities, and they would understand how much sweat they lost, and they would understand the composition of their sweat. And then we built this like recommendation algorithm that would then provide them with recommendations that they would then use in practices and games. Now, Gatorade isn't in the business to just provide, while their partners are a key component to their business. Their main thing is building to the consumer. And so the issue is that in order to develop personalization for the consumer, they would have to somehow recreate that lab in a product in order to deliver custom recommendations. In the interim of us developing that, we did do one test with this personalized equipment where we Smart Design and Gatorade built these bottles where you could personalize and customize those bottles. And as soon as we released them, Gatorade like couldn't sell them fast enough, and so we knew that we had something with personalization, and so there was a lot of pressure being put on to start to develop these custom formulas, and the ability to understand how people sweat so that we could deliver those custom formulas. And it was also the first time that Gatorade ever launched something that was a direct D2C um, website, because typically, other than that, they kind of went throughout it. So like it was a whole new line of business for Gatorade. And so that introduces the patch and primarily the thing that we're going to be talking about. So this is the thing that we needed to recreate in the lab. And we went through a lot of different iterations of this patch. But basically, the idea is that we needed to develop some sort of product that would be able to measure people's sweat and then thus be able to give acute like sweat recommendations. And in order to do that, Gatorade and smart design. So like going back to like the Internet of Things piece that I had on the previous slide, where just about like collecting a lot of data. There's no data out there about sweat. You know, there's no like open source data field where we can just pull it down and we just have like all sorts of this contextual sweat data. And so in order to do that, to basically build this sort of new backbone for what Gatorade will be as like this personalized fluid recommendation system, we needed a ton of sweat. And so we performed a lot of these pilots where initially it would be to do it the old school way that they were doing it with the pros, where we would just be collecting a lot of sweat. But that would just be the backbone of the first machine learning model we would then use in order to develop the product. So I have one more video that's going to show just how we did that at a triathlon, an Ironman event in Hawaii.
Gatorade has been sweat testing athletes for years. There's something magical when you look down on your arm and you see your actual sweat filling the patch. You know it's working, you know you're sweating, and you know at the end of your activity, you're going to better understand your own physiology and your own hydration needs.
We're here in Kona, Hawaii, where some of the best triathletes in the world come to compete in Ironman World Championship. This race is known to be one of the hardest in the world because the conditions can be really extreme. For the past 5 years, our colleagues at GSSI have been giving an immense level of athlete service to a select number of athletes on the island. We took 50 triathletes and showcased them this new technology, giving them an inside look of what they can do at home.
Gatorade has been sweat testing athletes for years. Now that we have a sweat patch, we can bring that service to any athlete who wants to better understand how much they sweat and what type of sweater they are, which allows us to make recommendations that they can use to better improve and optimize their hydration. One of the things we're most excited about is how easy the patch is to use. All an athlete needs to do is apply it before their workout. They go sweat, they come back, they finish their workout, they take a picture, that unlocks the results.
It's been incredible to interact with these athletes as they experience the sweat patch, and we look forward to bringing it to many more in 2020.
Cool. All right, so I know this is going a little long, so I'll try to get through this, although I do feel like this is like the most important part. So we performed countless iterations of the patch. We did a lot of sweat testing in order to build up these data sets. And so like the way that it works is that, you know, people wear the patch and then perform some sort of physical activity. You then use a computer vision algorithm that uses a camera that then pulls that information off the patch and then turns it into data points. And then it takes the reading that's on your arm and then uses another machine learning model that then applies it to your entire body to give like a sweat log of it. And then from there, we're able to give, you know, based on like an hour of you running, we're able to say like, this is exactly how much fluid you lost, exactly how much sodium you lost. And so the next time you were to perform said activity, here is a strategy in order to do that. And it's really unlocked a bunch of new things for Gatorade, not only from a personalization standpoint, but also like it has new categories of like endurance athletes who, traditionally aren't very trusting of a brand like Gatorade, are more interested in the brand because of the scientific nature of the patch and other personalization elements. So I wanted to just go over just a quick playbook of what Smart Design currently uses. I would say now we've done maybe like 7 or 8 computer vision, machine learning, AI projects, and out of everything, I kind of pulled out these 5 themes of like, these are the 5 things that we do pretty much on every single project, and I'll go into each one of them. And I'll use the sweat patch as a vehicle of how they're implemented within the sweat patch. So the first principle is validate and then accelerate. It does rhyme, but the meaning of it can be true of just any real innovation. Excuse me. So we're basically testing the theory. We're in this piece, we're testing out the theory that we can recreate the lab as a wearable. And so the first thing we want to know just is like, how does the tech work? And in fact, this patch, we tried actually a couple different iterations of the patch that uses different types of technology. I didn't fully explain it, but the first channel is it fills up with this blue dye, and that tells you how much sweat it has. And then the orange one is the sodium channel, and that uses a chemical reaction that shows how much concentration you have in your sweat, and it changes color based on the concentration of your sweat. So I'll cover this a little bit more detail of how we're able to validate this. But the ultimate piece that I want to take away from this is that like, we want to validate this in almost the most controlled environment as possible, and nothing necessarily needs to be automated. Like, as an example, like we don't necessarily even need to use a phone. All we want to be able to make sure is that, are we able to use this patch to accurately be able to give the same sort of sweat reading that they would be able to do in the lab? And then all the other sort of like accelerating, being able to automate it, being able to do it with a smartphone, all of those things can come later. But the founding principle is, can you do this within like just like the old fashioned way? And can it be repeatable? And then from there, we can kind of go into like, all right, how are we going to automate these things? So the second, and this is a very large, this is a very high level way of kind of how a lot of the models work, but is identify specific challenges and develop complex slices to achieve them. So within this project, and I've just named out a few, there are like a few key challenges. So the first one was, does a physical patch collect sweat accurately? And does the sodium channel chemical reaction work correctly? And so there was a way within all of these different types of validation, we wanted to create some sort of test set so that we could validate each one of these things individually. Because if we try to test them all at once, there was just too much noise, and we wouldn't really know where our models were failing. And so we would develop these test cases for each one. So that was number one. Number two would be how we pull this information off the patch into a device. And so we knew that we were probably going to be using computer vision to do that, but there were some other more low technical examples where basically someone would look at the patch and then be able to just use their thumb to do it. Fortunately, we were able to pull off the computer vision piece, but that was another technical challenge that we had to overcome. The third was, how do we translate local sweat readings into the entire body? And so that was another model that we had to develop. And the way that we did that was we basically developed a test set where we tested 300 athletes in a lab. And we did it the old fashioned way where we weighed them before and afterwards. So we knew how much sweat they lost. And then we would use the patch on each and every one of them. And then we would adjust the algorithm, and then we'd retry it. And then we would retry it until we would get the same results from the old fashioned way to the current way. And then we would add a much larger data set and continue. And so therefore, once you have a test set where you already know the answer, it's really easy to iterate on an algorithm to get into that like specific place. And then the last one is just environmental variables and how those play a role. So, people's sweat change pretty dramatically based on like temperature and humidity. And so, as we built some of our test suite models, we had to start including that once we got over the controlled environment. just to make sure that we were seeing things that were, um, you know, not in control, but also just as accurate as what we were seeing in controlled environments. The third is to pilot. I mean, this is some of like Smart Design's bread and butter, or any sort of design consultancy or design company, is just to test things in the field. The one thing that is probably pretty different about testing in AI and testing it from a design perspective, or just testing a digital product, is that we use these for two different reasons. One is we do it to test experiences. So if we're designing out like a digital experience that's going to accompany the sweat patch, this is a great way for us to test this in the field of how we're going to develop a service, and what are the opportunities and pain points that we would have to develop along the way. The second is it's a great way to create diverse data. And so I'm going to get into the next slide, but we would do this very often, where this, as an example, is at ING Academy. And we would collect a lot of data, and then we would also use that from an experience standpoint. The next one, which kind of goes hand in hand, is to develop these data ingestion prototypes. And so we developed two different types of prototypes. The first one was the experience prototype that we would then test in pilots for experience standpoint of having someone run through this and make sure that from a user experience standpoint, it's pretty in line with what we want to develop, and we would kind of learn along the way. The problem is that they were terrible at collecting data, because it just took a lot. You would have to input the athlete. They would then go through the entire experience. You'd then take a photo of the patch. It would only be one photo. And so it was just like a terrible data collection tool. So the people that would go to these pilots would be armed with two prototypes. One would be the experience, and then we would often Wizard of Oz the AI, because we didn't want people to evaluate where the AI was at that time. We wanted them to evaluate the experience itself as if it was already in the field. And then the second one would be almost a simple screen, that what you showed just right here, which is just a camera. It opens up, it identifies where the patch is, you take a photo of it, it gets a reading, it stores it in a database, and we do it a couple hundred times, and we do it with a bunch of athletes, and that's how we are able to create a much more diverse data set. And then the last one is understanding the intersection of design and engineering. As an engineer, I always want to try to find a technical solution to any sort of problem. And so this is a great example of that, where the sodium channel itself, you have to have like a really specific RGB color to make sure that you're getting the right sodium concentrate. And so when we initially started, we would use this sort of RGB color wheel so that we could ground the iPhone camera, because the iPhone camera auto adjusts color compositions, basically almost like a point and shoot, so that it takes good photos. The problem is that it's really hard from an RGB value to understand exactly what that is. And so we tried a bunch of we took a bunch of photos with this thing that you see right here, and we were trying to develop a model that would basically color correct it on the fly. What we ended up doing was, I'll just go back to the slide. As you can see, there's like these little dots right here. We just put the color wheel on the patch and we just fixed everything. And so like from that standpoint, like we could have racked our brains and spent 6 months and trying to come up with the technical solutions for it, or we just kind of solved it with design and added these color swatches. And we kind of, and that was almost like a 1-day solution that saved us like months of time. And then, yeah, in conclusion, these guided principles, like we use them for all sorts of AI projects, everything from computer vision to, we're doing a lot of work with smart sensing, with gas sensing and stuff like that. And all of these, from piloting, developing slices, creating different types of prototypes based on the use case, and understanding the intersection of design technology. We use all of them. So hope you got something out of this, but that's it. And I will open it up to questions if there are any.
Well, there are definitely questions. Yeah, first of all, that was like a whirlwind. Thank you so much for sharing it. I have 1,000 questions myself. I'm going to start digging into my 1,000 questions, but all y'all should put any contributions or questions or anything into the chat. And I'm going to try to pass the mic around as much as possible, but Yeah, start by putting them in there. So I think a super basic question that I have for you is I'm just curious about how the brief from Gatorade, like when they first came to you, what did they imagine they were going what was their vision? What were they asking you for? And I'm just curious how that brief and how this whole product line and this whole new offering developed over time. And to what extent was that, like, how far did it evolve? And then to what extent were you actively kind of pushing them to refine the brief to make it work, basically?
Yeah, I mean, over a 9-year period, you're gonna obviously get like a lot of briefs. I would say that, the first one, and it's pretty much right when I started Smart, was this sort of 3-day work session where they're just trying to come up with like it was the 50-year anniversary of Gatorade, and basically the brief was we wanted to try to think about what is the next 50 years of Gatorade. And ultimately, what we came out of that 3-day work session was that one hypothesis of the idea of every athlete is unique. We had a bunch of people that come in, including the Gatorade Sports Science Institute, that talked about sweat testing athletes, and then personalization was becoming in vogue within the design community as being the next sort of frontier of certain design elements. And so we took that lens and we thought, okay, that's actually kind of interesting. And then Gatorade Sports Science in the lab had started working on this idea of mixing formulas to match how people were sweat testing. And so the first thing that we said was like, let's not build out this entire thing for it, because obviously this hypothesis is very broad, but let's just try an experiment. And the first experiment was, and what Gatorade's amazing at is they have these partners, was, okay, we can do an experiment. How about we do it with the Brazilian national team at the World Cup? It's like, holy shit. Like, all right, I thought it was like high school kids would be cool. But so we started with that. And right when the moment we knew we had something was we mixed all their bottles, and we realized we didn't know how we were going to tell them which one was theirs. And so we wrote with tape and we put their names on it. And as soon as they saw their names on the bottle, they got super excited that it was like made for them. And like right there, we were like, that's it. And so that kind of validated that. And, a lot of the things that you saw on this, this is a very long, journey with Gatorade to kind of come to where we are now. But that was like kind of the moment where we really felt like we had something. Someone called out in the chat. I do want to say the patch itself, like the engineering of the epidermis sensors was made by this company called Epicor Biosystems, and they're doing really cool shit. So I did want to say that they were the ones that we partner with to develop that epidermis sensor.
And just real quickly on that personalization thing, is it just, I mean, I'm just curious how you understand personalization now. Is it just the sort of basic underlying vanity of an athlete or self-interest in an athlete? I mean, how different are people actually when it comes down to it in terms of their sweat? Like, is there a real difference, or is it just that people love personalization so it makes sense?
I think it's a little bit of column A, a little bit of column B. I mean, like, with working, like as an example, working with professional athletes, they're always looking for like that 2 to 5% edge, right? So like we would sweat test offensive linemen, and some of them would sweat 600 milligrams of sodium, and some of them would sweat 1,300 milligrams of sodium. And, some of them would have really a lot of problems with cramping, and it was because their hydration was an issue. Now, when it comes to the consumer, we would work with like elite high schools, and it's almost impossible to tell kids what to drink and what to eat, because they're going to do whatever they want. But when it comes to like endurance athletes, as an example, like triathletes, marathon runners, their hydration is really important if they want to perform better, or also if they're having issues with cramping or they're starting to feel lightheaded. It's pretty significant how different people sweat. And I was a little bit of a cynic too going into it. I was like, all right, how different could this possibly be? But just being someone that's kind of seen a lot of it now, it's, again, it's people go from sweating like 500 milliliters per hour to like 2,000 milliliters per hour. Wow. And if everyone's getting the same thing, you can only imagine that it's not going to be the same. So yeah, just also depends on how serious you're taking it too.
Right on. Vivek has a question. Vivek, do you want to ask it, or do you? There we go.
Yeah, I would love to. Just coming into reality here, John. Thank you so much. Super inspiring work. And I had a two-parter. I'll just blow into it. It's in the chat. Feel free to answer what you can. The first is, I love this idea of solving it with design as opposed to going, to building new tech. But I also know clients are like really excited about like new tech, and that's really sexy. I'm curious, can you talk a little bit about how you like sold the client on that design-based approach to like solve that problem, and any validation you did to pitch that? And then the second is just really excited how this spans disciplines. I work in higher ed and lead a master's in design tech program, and I was just curious, like, what kind of skills you'd recommend emerging designers and engineers like cultivate and invest in to lead innovation like you're doing. Thanks so much.
Sure. So the first question, I mean, Gatorade is a great partner. I think that like innovation isn't like a straight line. It's rigid, and so there's always like learning things that anytime you do these pilots, as an example, like it never goes the way you think it's going to go, but you're always going to learn something. And so I've definitely had like some cold sweats before pilots where everything breaks, and then you're like, oh my god, how are we gonna like? But then it always kind of like works itself out. I would say that like we traditionally try to not do tech for tech reasons. I mean, you're going to get a brief or an RFP where, we want to do a Gen AI project and we just want to do it. And then you kind of work backwards where you almost start with tech and then try to figure out how to work with design. But we really, and the Sweat Patch was actually a pretty decent example where we knew that we wanted to recreate it in the lab, but we didn't necessarily know how that was going to be implemented. And some of the other patches that were being made, some of them had RFID tags, some of them had tech in them. And we didn't get married to any single one of those things, because ultimately the thing that mattered the most if it was accurate or not. Now, the beautiful thing about the current Sweat Patch is that it's like really low tech in terms of, I mean, it's high tech in terms of like the sensors and that litmus that does the chemical reaction. But from like a business standpoint of like, they're really low cost to make. And so the ability to basically use like a smartphone as an example is like, that's going to be the tech you're going to use, and you're going to pull those information, and all of like the heavy duty stuff is going to be the things that happen on the cloud. It was a pretty cool way to execute on that. So again, kind of going back to your question, we like to tell clients that, we want to solve this the right way. We don't want to just use tech for tech reasons. However, there are times when those are the things that come up. And, if I were to able to use another example, where we're currently doing something right now with AI and edge computing, where we're having to make a lot of concessions about like the type of GPUs we're using, and like we have to build everything in C++ because it's faster and stuff like that. Like those are like concessions you have to make based on like the product we're building. And those are usually kind of go in the brief too. Now, when it comes to, what I would recommend someone now, I think that it's funny. In my career, I started where everything was being built on device or like on a computer, and then everything moved to the cloud, and I became a cloud computing, engineer, and that's predominantly like a lot of work that I did. And now all of a sudden, like all of my work and brief that I've been seeing is going back on the freaking computer. so like a lot of like the connected product work we're seeing, or like even like things that you're seeing on like the iPhone, there's just a certain amount of benefit of things being on device. And so the world right now, like the ML world and the AI world, that's predominantly built in Python, because of the similarities it had with data scientists. Python doesn't really work well on device because it's slow. And so what we're end up having to do is having to rewrite a lot of our work in C++, because it will be a lot better to work on edge. And so, but then like the community hasn't really necessarily completely caught up with that idea yet. And so I would say the next 10 years there's going to be a lot of edge computing stuff about getting these things more on like connected devices and less having to deal with cloud, because like you can only imagine that if you start a company that has doing all AI in the cloud, it's just going to be way too expensive from an operating expenditure standpoint. And so people are going to want to bring things on the edge. That was a really long answer. I'm sorry.
Awesome. Thank you so much.
Phil has two questions. So Phil, why don't you ask them both, and then we'll see what John does.
Well, he actually answered the first one, so I'll ask the second one, which
Great.
is about personalization and how does it scale, especially for a consumer product that people buy on a regular basis as opposed to a one-off. Like, if you're talking about a drink, are you pointing the consumer through your personalization to like one of 12 different things on the shelf? Or are you trying to get them to buy something unique on a regular basis, which would really impact your upstream production process?
Yeah.
How are you talking about personalization with your clients?
Yeah, no, that's great. Yeah, I mean, the manufacturing of like custom drinks is obviously the hardest part of that. And it's something that we were very cognizant of going into it. So what comes out of like the sweat profile is basically it knows exactly how much you sweat and the concentration of it. And then beyond that, we have this recommendation engine that I showed in one slide that is able to take that raw information and then provide you. So if you were to like, let's say you're training for a marathon, and within each marathon, each day you're running 6 miles, you're in 13 miles, whatever. It's easier with triathlon because it's a little bit more diverse, but we'll use marathon as an example. Based on that sweat profile, it's going to tell you, it's going to give you a recommendation that's going to say, you know, we want to give you, based on your run, we want to say that you're going to need this much amount of water for a pre-hydration. You're going to need this much water, salt, and carbs during it, and you're going to need this much afterwards. And we're going to provide you, and then Gatorade is going to provide you with their products as an example of how to fulfill those recommendations. Now, when it comes and so like you basically use that, and then you use the product matrix. And they showed the pods in the video, but the pods are a main component of that because the pods are a matrix of they have low to high sodium and then low to high carb based on those pods. And then so you use that as a way to then run through like the recommendation engine, and then that's the way that they buy those products based on your training. Now, like the next frontier of that, and it's similar to like what you see in like the nutrition space, like particularly in vitamins is like the first example of that. Although I'd say like most video I've seen has been customization, not personalization, but is like, how do you then manufacture your own custom formulas? So that is like kind of like the next thing. Whether or not Gatorade is working on that right now, I actually don't know. But I imagine that would be, if you're talking about like true personalization end to end, those custom formulas would be the last part.
And maybe we're at the very edge, but I can't help but ask this question. I'm just kind of curious, after having worked with this Gatorade and also with your other projects for so long, I'm just kind of curious about what you see as the future of IoT plus AI plus interaction. I'm feeling like it feels like AI is finally kind of unlocking IoT in certain ways and allowing it to kind of like come into its own in the way that we might have imagined it would have already. But I'm just kind of curious, like when you look on the horizon, what patterns are you seeing? What do you see on the horizon? What is your prediction for what's next, or what are you getting excited about?
I could probably say, just based on some of the work that we're currently doing on another project, was just like the incorporation of large language models within IoT. I think that like Moore's law, the allowing of sensors being smaller and smaller and more computational, just allows everything to be a lot faster and can compute things a lot quicker and a lot more complicated. So those are going to grow, and everything from the fact that like we're able to use like NVIDIA nanos on some of our IoT products, which is something that didn't exist not that long ago, to NVIDIA AGXs, which do much more larger computational stuff that has allowed us to just do way harder things on the edge. That is something that we couldn't do 5-10 years ago. So that's one. And then the other is like the output of that. We take that data and then we do with something with it. I think like the incorporation of more bespoke large language models that will be incorporated with some of the, like, like something like Gatorade, or something that like could be like a smart home product or something, that can almost deliver personalized content that uses some of like the general large language model pieces, but also then incorporates your own piece of data into it that then creates personalized content. That's something that we're like currently working on right now, and I imagine a lot of people working on it. So I would say next 3 to 5 years, you're going to see a lot more of that, and a lot more like action-based LLM work rather than just like chat-based.
Right on. So it's noon, straight up. There's Christopher has a great question, but first of all, I just want to say if you all need to split, that's fine. John, you probably need to split. I think you're like escaping from an all hands meeting or something.
I can do one more question, then I'm going to jump.
Okay, Christopher, you want to ask yours? It looks fantastic. And if
Yeah, I'm here. I don't know if you can see me, but yeah, the question was, there's this famous experiment. I don't know if you're probably aware of it after all of this scent and odor research you've done, but there's the famous sweaty T-shirt experiment. Klaus Witherkind, basically they found that these sweaty T-shirts, that women preferred certain pheromones from certain men. So there's a whole adjacency you could actually open up with all the research you've done, working with the partner that you've got that has been kind of cultivated over years, that you could actually do something with sweat and attraction on a whole new platform with a whole new brand, which would be amazing, right? You'd have, think about, Tinder or whoever you'd want to collaborate with, in some sort of a drink at Lollapalooza, or this kind of, concerts and festivals, what you could actually create, So have you thought about these kind of adjacencies? That's my question in the end.
Definitely on wearables and wearable clothing, not in that perspective. I think ultimately we kind of, we are a partner with Gatorade, but we go with a lot of what they're looking for from a brand perspective. However, what I will say, just as like a last little anecdote, just about like sweat and sweat profiles, is that, and t-shirts, is that if you ever go to the gym and you're sweating and you notice that you have like a white ring around your armpits or your neck, that means that you sweat a lot of sodium. And so if you've felt like inadequate with like what you've drank, or felt lightheaded or anything like that, that means that what you're probably drinking isn't giving you enough electrolytes or sodium back into your body. And so therefore your body is deficient in it. And that will cause like side effects like being lightheaded or dizzy. So if that happens to you, that's a small little anecdote that I learned from some sports science.
That happens to me all the time. I'm a marathon runner from the past. My knees don't hold out now, but I get headaches if I don't have enough salt. I have to add salt to food, otherwise I get headaches.
Yep.
So yeah,
Yep.
cool.
John,
Cool.
Thank you.
thank you so much. The accolades are coming through the chat, but that was super. It was fascinating. And so thanks a lot for taking time out of your day today to share with us.
Yeah, thank you so much. I loved it. It was really fun.
Right on. And check out for all of you, check out the Future Spaces website, sign up for more sessions. There's going to be a great one tomorrow. And then, like I said, we have a few slides. We'll just go through that, Joyce, real quick. Is that right? Did Josh want to do that? Forget it. Go to Future Spaces website. You'll see it all. We'll see you at the next one.
Awesome. Thanks all.